All right, our second guest is Thomas Kessler. He is the CTO at the AI think tank Genie Enterprise, and today he will talk about smart farming, one smart farming solution. As you might know, IDS is located in a wine region, and thus we are really excited about this solution because it's a solution which is used in vineyards to protect the leaves. So then, Thomas, the stage is yours.
Yeah, hello everyone. Thanks for having me. So let me share my screen. Here you go. Well, let's start with what is digital farming about? It's about applying the most recent achievements from computer infrastructure and information system and data processing to the agriculture. So here we go. So what does this mean? So if we think of a classical farmer, he has to take care about his plants. He has to take care about process fields. He needs to know when to apply which kind of processing to the fields. He must make sure that there's no damage or insects destroying his crop. Same applies also to the livestock. It needs to be healthy. It needs to be also, we have we need to measure the well-being or the healthiness of the livestock, and that it's everything fine, so that we comply with the general rules how to grow animals, and also just to increase the quality and the amount of animal products we can produce. So it's about not having knowledge about what you're doing and when, to which crop, to which field. And it's very specific, as the fields are very different, just depending on the local climate, the local conditions of the soil. And all this knowledge has traditionally been just given from father to son, or from one worker to the next one. So this is where digitization comes in place, to conserve this kind of knowledge, to make it easier for the farmer to do his job, especially when the farms grow, or it's a common trend nowadays, farms grow. So there's more and more fields to have in mind and to keep in mind what's happened, and also to track what happened for which field, when. For example, also when you apply plant protection or so, you need to document those tasks very precisely. And this is where smart farming comes in place. So it's about collecting data. So first is just to document exactly what happened, when, to which field, when which crop was brought out, and what was the yield of the harvest at which point in the field, what's the quality of the soil, what's the condition of maybe the single plant or a field, if you can't measure it that precisely, and also about the machinery, precisely track what machines have done which task at which operating hours at which point, so that you also can apply classical predictive maintenance to your machinery, and just have your systems up and running when harvest is coming, so that your harvester doesn't break just when you have to harvest. So it's also something that's important in this place as well. So, and if we see those kind of applications, how they work, so we have classical tractors, for example, equipped with sensory, which exactly track the position of a tractor and also measure for example, the amount of plant protection that has been taken out at which point, or maybe what exactly amount of corn could be harvested. Or so there's different layers of information that you can collect over the time about your fields. And those systems are exactly integrated into tractors nowadays. So this is nothing new tech for the future. This is happening for years now already, so that tractors are tracking precisely what happened when. So now the farmers have some years of data available, and now classical machine learning and comes in place to do some kind of predictions at which place most probably how much amount of yield can be expected from which kind of crop. And so the farmer can optimize and plan on the computer exactly where to apply which amount of, for example, protection, or where to seed which amount of seeds. And everything is that's tasks that the farmer can do on this laptop at home or computer at home. And this kind of planning goes that far that the person operating a tractor exactly knows where to do which kind of job. And also the machinery attached to the tractor is automatically guided and configured, for example, to apply on a per plant basis which amount of plant protection, for example, to apply to which square meter or maybe even plant. So that's something that happens already today. So we have a kind of a trilogy of tasks here. First is sensing, so understanding exactly and seeing, smelling what exactly happens where. The next one is planning, so you need to plan where to do those things, and then to act. We already have heard about computer vision, for example, in the sorting field. Same applies to the fields as well. So cameras can be applied, also near infrared can be applied to detect the quality of the soil or the configuration of the soil. Then planning can be supported with AI to predict or suggest some when to apply which kind of crops to which field, for example. And then act. Nowadays, we have to see that autonomous driving is applied to the fields, to the farming industry, just we see as with autonomous driving. But autonomous driving on the field is way more easier than doing it in the streets. So this is quite advanced. So this is an example of John Deere, which have autonomous tractors ready to market. You can buy them and apply them to your fields, and they run perfectly with predefined tasks and operate exactly what you have planned on your machinery at home. So now, as we are in a winery region or in a wine growing region, one of our main interests is about wine. And now I want to present a solution that we are researching on to support wine growers, vineyards in producing healthy wine and have their the vine leaves and the vineyards in a healthy state. One major issue is that some kind of infections with bacteria or with yeast or whatever is not just locally on a single place, but it spreads. So it's crucial to identify the locations of which disease is where and how to treat it properly. That you track that and mark exactly in your documentation where the problematic vines are growing. and then plan application of treatment appropriately. And how do we do that? So in regular intervals, the farmers have to apply some kind of plant protection. And this kind of tractor runs through the vineyards, just equipped with some AI-powered cameras. We have trained a specific machine learning model with images from healthy and unhealthy leaves, and deploy these kind of models to cameras. And then while the tractor is traversing through the vineyard, the camera detects is that amount, or is that currently seen wine, grape, or the leaves, are they healthy or not? And that's correlated with the GPS signal and the position of the tractor in the field, so that we precisely get a map, just like we've seen before, where we have healthy wine and where we don't have. And then we can apply, or the farmer can think of what needs to be done, maybe just nothing, which is also often happening, or maybe applying a specific treatment just for this area in the field, or maybe do some manual processing, which might be also necessary, but as workforce is expensive, you need to direct the workforce properly to the areas where the problematic section is. But another mega trend in smart farming is using drones. At the moment, most drones are flown by human operators, but they know exactly where to fly and then apply the plant protection, like in this image here. And but autonomous drone fleets are also coming soon, so that it's something that can be done automatically, regularly, so that the affected regions in the vineyard are easily be identified and can be treated. So you see here, there's some infected leaves visible, and just only those vineyards are treated. So this is something where we apply the sense of vision. Another sense that's very crucial to the wine industry is the sense of smell. Wine aroma is a quite complex topic. If we think of a wine aroma, maybe like for a Sauvignon Blanc or so, you might have green pepper, you might have some tropical fruits in it. And all these flavors that you can smell are made from some substances, some molecules. But not only one molecule, this is a mixture of up to 2,000 different kinds of molecules that are present in the gas phase of a wine. So it's, if you think of, okay, we want to measure the wine aroma in a digital way, so you need to measure the concentrations of many, many, many different molecules and do that quite precisely. So from the chemistry, it's pretty well known. If we isolate a single molecule, what's the perception of that kind of molecule for a human being? So that's pretty well known, but it's pretty complex if you have mixtures of those. There might be combinations of 3 molecules in the first mixture. The same substances make up a smell of rose. If you increase the concentration of one of those, it might smell like cat pee. So that's unfortunately true. So it's not that easy just to measure the presence of those molecules. You also need to measure quite precisely the ratio of the concentration of those molecules. And also the total concentration, as human perception, is a little bit tricky. So we have kind of a curve from which we start perceiving a molecule, and then we perceive it and also detect the increase of the intensity. But then at some point we can distinguish how intense it is, as it's just too much for our human nose. So, and the goal of our project that we have is to identify an sensor device that's capable to do this kind of measurements, and also to predict the perception of molecules by a human being. But perception of human being is also not that similar. So we might have one person which is an oenologist. Sorry, need to get this away. Can I get this way? So the first one would be, okay, this is the oenologist is very precise in what's happened to the wine and how it was fermented and produced. You might have a sommelier, which has a clear description of, in a normalized language, of how that is done or how that is perceived. Then we have a person that just remembers someone else. So we have an episodic memory. And what we now do here in our project, Pinot, we in the first hand, we develop a system that is capable to do the measurements. So this is a combination of high-end detection. It's a combination of different spectrometric sensory and a new kind of sensory based on photoacoustic sensory. This is more or less the lab deployment. Will be at the moment, at the current time, the installation is pretty big, just as big as maybe 15 square meter room. So it's quite an installation. The plan is that we deploy those kinds of systems to the wine production, to the fermentation phase, and also to the ripening phase, where we have to identify those kinds of gases which are lowering the quality of wine, and also measure those gases or those aromas which are quality producing. The quality decreasing gases are pretty easy to check. You might remember sulfur hydrogen, for example, which you can smell in very low concentration. But for example, the aroma of rose needs to be really intense that you at least can perceive it. And on the other hand, we have we are building especially for the quality lowering substances. We're testing hundreds of different sensors and how they could detect various aspects of those gases. And where does the AI come in place here? So on the one hand side, we have the selection of the sensors. So we have millions of different combinations of sensors that could do the job, but we just want to have those ones which do the job the best. And for the spectrographic elements, you have seen the hyperspectrum curves in the last presentation. It's pretty much the same thing here as well. So we have millions of measurements, millions of data points that might be an indicator for the presence of a molecule or not. And AI comes in place to analyze those sensory data and predict for what exact molecule, what is the concentration. And on the other hand, we need to eliminate subjective perception. means for the various persons that we need to label our gases or the wines with aromas, they don't agree on a specific perception. They're subjective. And we need to identify what's the reason why which person is perceiving a specific aroma in what direction. How can we leverage that in describing the wine? Well, the final goal is that we fill in the wine and the system prints a fingerprint of the wine in terms of an aroma description that's human understandable, means we have kind of a spider diagram or a written description of what is the taste of the wine. This is the team we are working on it. It's a project funded by the Federal Ministry of Farming. And yeah, we have some nice partners gathered in our project. Just some words about us, the Genie Enterprise. We're a think tank company. We're not just focusing on sensory, but we build some products on our own. We have seen the wine topic. We have an NLP-based product to understand documents and some other services, but mostly we're researching on new solutions and developing solutions together with our clients. And well, this is the know-how on one slide. So you're usually doing everything from language processing to vision and everything that's needed to do it around. Thanks for your patience and listening to me. And I'm looking forward to your questions.
Thank you very much, Thomas. So there are questions. Which state of a disease can your system detect? And your images showed necrotic spots, but for effective spraying, the disease should be detected much earlier, even when not visible for humans.
Right. It was 2 questions. So with the standard camera system that we are using here, we only can detect diseases when they're clearly visible. So cannot detect diseases when it's emerging. It's not possible with this kind of solution. In this case, additional kind of sensory will be needed. For example, also applying near infrared or other kind of camera systems. Yes, for sure. If you have those kinds of spots, then spraying doesn't protect that single plant, but you can protect the plants around. So once that plant is affected, you at least can protect that it's spreading in your vineyard. So that's the goal or the idea behind. If you don't apply such kind of technologies, it's the detection of diseases only happens when the farmer is manually or walking through the field and really seeing what's happening. And this kind of tool, it's also happening when his employees are traversing with the tractor, and it's very precise to detect where the stuff really is.